Okay, hi. In today's lab, we are going to spectrophotometrically determine the concentration of blue dye number 1 in some consumer samples. We'll do this by generating a calibration line and then comparing our commercial samples to it. Blue dye number 1 absorbs light at the blue region, which is 630 nanometers. And the absorption will increase with the concentration. So by plotting the absorption versus the concentration, we should be able to find the concentration of blue dye number 1, or anything that's absorbing at 630 nanometers, by comparing it to that standard line. This line should be a straight one of the form y equals mx plus b, where as usual x is the concentration, the absorbance is y, b is the y-intercept, and m is the slope. So you probably want to rearrange to solve for the concentration. X equals y minus b over m. This should be outlined pretty completely in the lab manual. Here's the general procedure. We'll create some standard samples and record their concentration and their absorbance at those concentrations. So record the concentration of blue number 1 you are using. It should be 8 milligrams per liter. Make 4 standard solutions. One is pure distilled water, no blue dye at all. The other one is 1 part blue number 1 for every 3 parts of water. That means 5 mils of blue number 1, 15 mils of water. Half and half right there. And then all blue number 1 solution. Use the general formula. The original concentration times the original volume should be equal to the new concentration times the new volume, and get your concentrations in milligrams per liter using that method. Generate your calibration line using Logger Pro. I'll spare you all the gory details. A little bit about transmittance and absorbance of light. Transmittance would be 0%, would be nothing's getting through the cuvette at all. We have 100% absorbance. 1 or 100% means we have 100% transmittance. Everything's getting through the cuvette. Nothing's absorbing at 630 nanometers. And we have a log relationship, and so for absorbance it can go up to infinity. 0 means no absorbance, complete transmittance. Infinity means complete absorbance, no transmittance. To calculate the concentrations, we'll do what we said here, solve for concentration. And in your lab report, we're looking for 3 things total. 1, the concentration of your standard solutions right over here, these 4, only 2 of which are even diluted at all. This is C1V1 equals C2V2. The concentration of your original consumer sample, ignoring the fact that it was diluted by a factor of 2, and the concentration of the consumer sample when you account for the fact that it was diluted by a factor of 2. Note that this can be done by the computer if you follow the steps exactly. Okay, that is today's lab, and we will see you at 6:30.